session, sir.
Yeah,
So
yeah,
we have
sure, sure.
reached 50 and it's already 7 p.m. So good evening and warm welcome to all the esteemed participants joining us today. I am Dr. Sudipta Kumar Ghosh, Assistant Professor, Bharatiya Vidya Institute of Management Science, Kolkata. And I feel honored to be your convener and moderator of this faculty development program on multivariate data analysis and structural equation modeling using SPSS. This program organized by Bharatiya Vidya Institute of Management Science, Kolkata, in association with SPSS and the Indian Economic Association. We are really thankful to SPSS and the Indian Economic Association for their wholehearted collaboration for this program. In the evolving landscapes of academia, staying abreast of the latest tools and methodologies is crucial. This FDP, scheduled from 28th November to 2nd December, promises to be a transformative experience, equipping us with valuable insights into multivariate data analysis and structural equation modeling using SPSS. So today, Dr. S.P. Mahapatra, Principal Sir of Bharatiya Vidya Institute of Management Science, Kolkata, is present over here. And today's resource person, Dr. Suresh Kumar Sharma, Professor, Department of Statistics, Panjab University, Chandigarh, is present here. Welcome you, sir. And today we'll commence the session with a welcome speech from the our very own Dr. S.P. Mahapatra, sir. Please, sir.
Yeah, thank you, Dr. Sudipta. And I'm seeing most of the participants have already joined. Good evening, one and all present in this platform. A special thanks to our guest of today's session, Dr. Suresh Sharma. Sir, heartfelt thanks to you for your valuable time for our FDP.
Thank you.
And I can tell you that when we plan any research-related faculty development program, we have always got very good response from researchers across India, and similar response we also have received in this FDP, which is named as Multivariate Data Analysis and Structural Equation Modeling using SPSS. Our thanks to Indian Economic Association and SPSS for their support in organizing this FDP. We can say that research is very, very inevitable in today's context. As we say, for life, water is important. So for an academician to progress, to grow, research is very much important. Research not only says that how much we don't know, research also helps to understand how much we need to know. Research has got its strength. Am I audible?
I think somebody is writing no sound. I think
you are audible.
You are
sir.
audible. Maybe
audible.
Yeah.
Maybe some participants.
Yeah. So when we say any focus on research, this bound to have lot of takeaway at the end of the session. And these topics, when we look into this multivariate data analysis, whatever we have designed here, it may be common. But the best part of research is the more we discuss on it, it gives a better on the interpretation part. I can tell you that the day we feel that we know everything in research, that is the last date. So we cannot grow at all. So it is something, let us discuss more and more, and let us know how better we can use the research tools. And accordingly, today, the distinguished feature of this FDP, I can tell you that we have picked the best resources across India. We have tried to make it a national FDP rather by picking up guests from across India, and you must have seen our brochure. To start with, today we have Professor Dr. Suresh Sharma ji from Panjab University, who will be deliberating on factor analysis. And some of the researchers here may feel that the sequence would have been little in a different way also, but looking at the availability of resources, you may have something little bit in a different order. But I am sure you will not have any difficulty in understanding, because each one can be deliberated in a different manner. And today, while factor analysis discussion will be there, I am sure little bit of regression discussion will be there, but each area we will focus in a very different way when we'll go to different sessions. My special thanks to all the participants and my dear colleagues who have joined from Bharatiya Vidya Bhavan also. And I would like to inform all of you that our Honorable Director, who was supposed to be there to deliver the inaugural address, is again busy with another meeting, and at some time he may join. And he has sent all the good wishes to all the organizing members. And my thanks are due to Dr. S.K. Ghosh, who has taken time since last 7-8 days and trying to give the best possible inputs through the best possible resources to all of you. Now, without wasting much time, let's now go on to our today's guest. May I request Dr. Sudipta to have a brief introduction of Dr. Suresh Sharma, if it is there, Sudipta?
No, sir.
Yeah, I will straight away go to sir. I would like to request you to have a little bit before you start your session about yourself, sir.
Yes, because sir is really hesitating to share his whole details because he is too much humble. So maybe he can respond to your response. But before going to Professor Suresh Sharma, I just want to underline the rules and just a few rules to conduct the session in a very smooth way. So I would like to request all the participants to mute the audio and turn off the video. If you will have any doubt or query, please drop a message in the chat box. Sir will definitely respond to your query, but please don't turn on your video without the permission of the resource person. So this is our request. And also at the end of the session, there will be a question and answer session for further doubt clearance. And attendance will be collected at the end through a feedback form. So this is few rules we have to maintain to run the faculty development program for next 5 days in a very smooth way. Thanks to all the participants. Thanks to Principal Sir. And now I will go to Professor Suresh Sharma to continue the session.
Okay.
Please.
Thank you so much. Good evening to all the participants. First of all, I would like to thank the principal, Professor S.P. Mahapatra, and the coordinator of this program, Dr. S.K. Ghosh. They have really taken a very good initiative to educate people throughout the country. And they are doing this program very often. Even 2-3 months back, I think they have already conducted one workshop with Chennai people. Now this is with SPS and economics people. So I welcome all the participants to this program. A little bit of background from where I am. I am professor in the Department of Statistics at Panjab University, Chandigarh. And I was also the coordinator for system biology and bioinformatics for almost 9 years and the chairperson of the department from 2006 to 2009. Basically, I'm working into the area of biostatistics, into the area of cancer, ophthalmology, forensic science with a lot of doctors from PGI Hospital in Chandigarh, as well as WHO, World Health Organization, and ICMR, Indian Council of Medical Research. So, but statistical techniques, whether they are used in medical sciences or management sciences or biological sciences or social sciences, they are very much similar. Only thing is terminology we need to understand. And today I'll quote many examples from maybe management sciences so that anybody can understand. Basically, I started my career in 1994 from after completing my PhD, then joined as a lecturer and now as a professor since 2009. And I have worked with several projects all over the world. Recently, I came back from US. I was working as a visiting professor at NIH, National Institute of Health in US, and also done a project with the VA Medical Center in Dallas, Texas. I'm also on the board of directors of London School of Management Education and having about 150, more than 150 publications with some honors and awards. Of course, with this little bit of background, I don't want to waste much of the time. So I'll start with the presentation. Let me share the screen so that you can understand the things in a better way. Let me share the screen. Just a minute. Is that my screen is visible? The desktop is visible or not?
Yes, yes, sir.
Yes, sir.
This is visible, right?
Yes.
Yes, sir, it is visible, sir. Please continue.
Okay. All right. Is there any way to hide this slide? Because this. Anyhow. All right. All right. So this is a faculty development program on multivariate data analysis and structure equation modeling using SPSS. Now, as mentioned by the principal, that we are little bit off the track in the sense that we have started with factor analysis first. But to link up the things, since factor analysis can be covered in 45 minutes, so I'll come to certain basics so that anybody can understand. If you are from statistics or management background, don't worry at all. I'll start from very basics with the research methodology part, then some basic statistics, and then come to the factor analysis. Because factor analysis is a multivariate technique. But before we go on to multivariate technique, we need to understand what do you mean by univariate, what do you mean by bivariate. So first of all, I will focus on research methodology. And in order to carry out any type of research, it's very important to understand the nature and types of data. Unless or otherwise you are not familiar with the nature and types of data, it is not possible to carry out any type of research. So first 10 to 15 minutes will be very, very important. Let's look at the nature and types of data. If you look at the nature of the data, it is basically of two types. Either it is called structured data or it is called unstructured data. Now, what do you even mean by structured data? Structured data is the one where features can be easily extracted. For example, if I give you 100 observations, say related to height or weight or BMI or blood pressure or cholesterol, and I ask you to find out what is the minimum value, what is the maximum value, what is the mean, median, mode, skewness, kurtosis, percentile, decile, you can easily compute because they are in the numeric form. So this kind of data, which is in the numeric forms, where the features can be easily extracted like mean, median, mode, etc., comes under what is called structured data. What happens sometimes the data may not be exactly in the numeric form, but it's easily convertible into numeric form. That kind of data also comes under structured data. For example, gender. Now, gender is not numeric as such. It's a label, male and female. But I can assign certain codes. A male has 1, female has 2. So it becomes numeric. Similarly, socioeconomic class, say lower class, middle class, upper class. I can write 1, 2, 3. Severity of disease, mild, moderate, severe. You can write 1, 2, 3. Different colors can be coded. Hair colors, skin colors can be coded. This kind of data, which was initially not in the numeric form, but once you assign certain codes, it becomes numeric, is also counted under structured data. So what is basically structured data? Either it is already in the numeric form or it's easily convertible into numeric form by assigning certain codes. This is what we mean by structured data. Then there is unstructured data. What is an unstructured data? Unstructured data is the one where features are not easy to extract. For example, everybody is using WhatsApp. There are thousands of messages, videos, pictures. People are putting their comments. Do you think it can be converted into numeric form at the end of the day if you are receiving hundreds of messages every day? It's not possible. But information is there. People are talking about something. This kind of data, which is not in the numeric form, it is in the textual form, like email or Facebook comments or Snapchat or any social media site like Twitter or Instagram, you see a lot of information is there, but that is not in the numeric form. This kind of data comes under what is called unstructured data. It's easier to deal with structured data because structured data is in the numeric form. Very difficult to deal with unstructured data. And two of my students from bioinformatics and two from statistics, they have completed their PhD on unstructured data. But as far as this program is concerned, I will only focus on structured data, because to cover the unstructured data, you need to learn so many other things like artificial intelligence, machine learning, data science, and support vector machine and Dirichlet's integral, etc. That is beyond the scope of this program. Sometimes also people talk about big data. Big data is nothing but a combination of structured and unstructured data. Some part may be structured and some may be unstructured. So as I mentioned, this is all about the nature of the data. Let's look at the types of data. Since we are focusing only on structured data is basically of two types. Either it is called categorical data or it's called measurement data. Now, what do you mean by categorical data? Categorical data is the one where measurements are in terms of categories, like gender, like education categories, occupation categories, marital status. All these are categorical data. What is a measurement data? Measurement data means some kind of instrument is being involved in measuring something like height, weight, blood pressure, cholesterol. You require some kind of instrument. But sometimes we do not require an instrument, but still it could be a measurable quantity. For example, to measure age, we don't require any instrument, but age can be measured in years. You can add months, even days, minutes, and seconds. So it's a measurement. Temperature is a measurement, right? So these are the examples of categorical data, like hair color could be brown, it could be red, it could be black. I can write 1, 2, 3, 1 for brown, 2 for red, black for 3, let's say. I didn't put a white there because people sometimes get depressed, right? Our entire body is made up of 4 types of nucleotides. They are known as ATGC. These are known as 4 bases. So I can write A as 1, T as 2, G as 3, C as 4. Eye color can be coded as 1, 2, 3, 4. Gender can be coded as 1 and 2. Disease, mild, moderate, severe, you can code this as 1, 2, 3. And genotypes, depending upon which one is recessive, which one is dominant, you can write 0, 1, and 2. So all this kind of data, which was not in the form of numeric, is easily convertible into numeric form by assigning certain codes. And this is what we mean by categorical data. Then we look into measurement data. Measurement data is self-explanatory, like cholesterol, it's a measurable quantity. Height is a measurable quantity. Age is a measurable quantity. This FPKM value is generally called fragment per kilo base per million. Whenever we conduct this, DNA is very, very large. DNA in any cell is very, very large. It's 3 into 10 raised to power 9. Very difficult to study DNA. Then we take a fragment of that DNA, put that into a machine that is called Illumina, and the entire information comes out in terms of ATGC. Then there is mathematical formula to quantify that ATGC into expression level. Those expression levels, which is in the mathematical form, are known as FPKM value, which is called fragment per kilo base per million. Now, time is also a measurement. If you look at any kind of measurement data, it is basically of 2 types. Either it is called a discrete measurement or it is called a continuous measurement. What do you mean by discrete? Discrete means if certain isolated values are present in your data, then it is called a discrete measurement data. Like number of members in a family. Number of members in a family may be 5 members, 7 members, 8 members, 3 members. I cannot say number of members in a family is 3.6. It doesn't make any sense. So it's going to take some certain specific values. Then we say that it is a discrete measurement data. Number of members in a family, number of errors in the book, number of students present in the class. So all this kind of data, which is going to be a complete integer, comes under what is called a discrete measurement. And what is called continuous measurement? That means it is capable of taking all values within certain specified range. For example, height can take all values within decimals, also 157.5, 157.57, depending upon the accuracy of your instrument. You can add 3rd, 4th decimals. Age could also be 26.5 years and so on. So that means continuous data can take even decimals. But discrete data, for example, how many genes are expressed in the body for a particular kind of disease? So it's a discrete measurement because maybe 5 genes are expressed or maybe 2 genes are expressed. It cannot be 2.5. Either it is 5 or it is 2. So hopefully you understand the meaning of discrete and continuous data. Now, this is very, very important. So far, we discussed that there is a categorical data, there is a measurement data. And they are measured on different kind of scales. Knowledge about these scales is very, very important. Because many of the softwares like SPSS, R, SAS, Minitab, they will ask you, your data is on which kind of scale? And if you don't have any knowledge about these scales, you will face difficulty in the analysis. So there are 2 scales associated with categorical data. What are these 2 scales? Nominal and ordinal. What are the 2 scales for measurement data? Interval and ratio. So I won't take much of the time. I'll just explain you a little bit. What do you mean by there are 2? Please remember 2 scales for categorical data, nominal and ordinal, and 2 scales for measurement data, interval and ratio. So I'll quickly go through what for the categorical scales, nominal and ordinal. First scale is nominal. Nominal means a type of categorical data in which objects fall into unordered categories. That means you cannot order the categories, that this will come first and this will come later. For example, gender. Everybody is human being. I can write male as 1, female as 2, or somebody can write female as 1, male as 2. Doesn't make any difference because you cannot order. Similarly, religion, Hindu, Muslim, Sikh, Christian. You can write in any order. I can write Hindu as 1, Muslim as 2, Sikh as 3, or you can write Sikh as 1, Muslim as 2, Hindu as 3. Doesn't make any, Christian as 4. Doesn't make any difference. Everybody is human being. So bottom line is, if all the categories are given equal weightage, let me just repeat, if all the categories are given equal weightage, then we say that our data belongs to the nominal scale. Examples of nominal scale. What is your gender? Gender is nominal scale. Hair color is nominal scale. Where do you live? It's individual choice. So that is a nominal scale. Then the second scale is called ordinal scale. Again, for categorical data, there are 2 scales, nominal and ordinal. Now I'm coming to the ordinal scale. A type of categorical data in which order becomes important. You can order. For example, let's say socioeconomic class. If I'm writing lower class as 1, middle class as 2, upper class as 3. So you can order. 1 means the lower, 3 means the upper income group. So you can order them. Education categories, primary school, middle school, high school, graduate, postgraduate, you can order them. So one can arrange the categories either in ascending or descending order of magnitude, which is not possible in nominal, but it is possible in ordinal. But whether you are dealing with the nominal scale or you are dealing with the ordinal scale, numerical distance between any 2 categories doesn't have any significance at all. What does this mean? For example, if I'm writing male as 1, female as 2, now subtract 2 minus 1. It doesn't have any meaning. Similarly, say lower class as 1, middle class as 2, upper class as 3. Subtract 3 minus 1 or 3 minus 2. It doesn't have any meaning at all. So remember, numerical distance between any 2 categories in categorical data doesn't have any significance at all. Examples of ordinal scale. How do you feel today? In fact, today is the first day of the workshop and you are attending the first lecture. So you can very well imagine, where do you stand? Very unhappy, unhappy, okay, happy, very happy. So where do you stand? You can recognize yourself. If you are 3 and above, then there is no problem. Okay, very happy or very happy. But if you are below 3, then this talk is not for you. Anyhow, how satisfied are you with our services? Very unsatisfied to very satisfied. The idea here is you can arrange the categories in order. Sometimes we go to a very good hotel or sometimes to a bank. They will give you some feedback pro forma. There are questions like, how do you like the ambience? How do you like our services? Very unsatisfied to very satisfied. So hopefully now when such type of questions are there, you can understand that these type of questions are on which kind of scale? Ordinal scale. So these type of questions, they are on ordinal scale. So you can understand now. That's all about the categorical data. Now the categorical scales are over. Let's move on to the next scales, which is called measurement data. Measurement data also has 2 different scales, and slide control. No, there is nothing. Anyhow, see, in interval scale, this is for, there are 2 scales for measurement data, interval and ratio. Try to understand, please, because the knowledge about these scales is very important and people get confused between these scales. What do you mean by interval scale? In interval scale, sometimes the mathematical operations may not be valid. Let me give you an example. Let's say some beauty contest is going on and there are judges, say, giving score out of 10. Let's say first person gets a score of 8 out of 10 and second one gets a score of 4 out of 10. First one gets a score of 10, 8 out of 10 and second one 4 out of 10. Now, if I divide 8 by 4, your answer will be 2. But I cannot make a statement that the person whose score is 8 is exactly twice the beautiful than the person whose score is 4. You cannot make such type of statement. Let's say one student has scored 90 marks in a test. Another student has scored 30. Divide 90 by 30. Answer is 3. But I cannot make a statement that the student whose score is 90 is exactly 3 times the intelligent than the student whose score is 30. He may be intelligent in sports or in some other category. You cannot make such type of statement. That means some mathematical operations are not valid. Moreover, in interval scale, 0 always has a meaning. For example, 0 doesn't mean the absence of character. For example, if I say temperature 0, do you think the temperature is absent? It is still better than -5. So that means even at 0, temperature exists. If somebody has scored 0 in a test, it doesn't mean the person is not intelligent at all. Maybe on a particular day, his or her performance is not up to the mark. Next time he or she can score better, right? So 0 doesn't mean the absence of character. That means 0 has a meaning in interval scale. That's why in interval scale, 0 is counted as an arbitrary 0, not the true 0. True 0 means quantity doesn't exist. Hopefully, I have given you enough examples of interval scale like beauty score, intelligence score, temperature, etc. They're all measured on interval scale. To overcome, there are problems with each and every scale. Sometimes the order is not possible. Sometimes the division is not possible. To overcome all such difficulties, there is a highest rating scale, and that is called the ratio scale, again for measurement data. Let me give you an example of ratio scale, where all mathematical operations are valid. Let's say some person is having weight 90 kg. Another person is having weight 45 kg. Divide 90 by 45. Answer is 2. But you can always make a statement that the person whose weight 90 kg is double the weight of the person whose weight is 45 kg. Nothing wrong with that. Let's say age of the father is 45 years. Age of the son or the daughter is 15 years. So I can say that the age of the father is 3 times the age of the son or the daughter. You can divide, you can multiply. But very important point to understand in ratio scale is about 0. 0 here is a true 0. True 0 means quantity doesn't exist. For example, if I say height 0, it doesn't exist. If I say weight 0, it doesn't exist. If I say age 0, it doesn't exist. So 0 has a meaning in interval scale, but 0 doesn't have any meaning in ratio scale. If all these things are clear, then you are through with all these scales. Hopefully, this makes sense to you. So that's all about the different kind of scales. So here is a summary of different kind of scales. I have put in all the 4 scales here: nominal, ordinal, interval, and ratio. You can see them. And then generally we are involved in counting. Now counting is possible in all the 4 scales. In nominal scale, I can count how many males, how many females are there. In ordinal scale, again, I can count how many people belong to the lower class, middle class, upper class. In interval and ratio scale, you can divide your data into small intervals, say 10 to 20, 20 to 30, 30 to 40, and go for the counting. So counting is possible in all the 4 scales. But how do we compute median? We arrange the data in order from the lowest to the highest. We arrange the data in order from the lowest to the highest, and then look at the middlemost value. Now, do you think it is possible to arrange the data in nominal scale from the lowest to the highest? It is not possible. So median, etc., doesn't make any sense in nominal scale, but it makes sense in ordinal. It makes sense in interval and ratio. Here, the ordering is possible. Order of the values is known, that this will come first and this will come later. Only under nominal, interval, and only under ordinal, interval, and ratio. Can quantify the difference, as I mentioned already, that difference, etc., doesn't make any sense in nominal and ordinal, but it makes sense in interval and ratio. Can add or subtract only in interval and ratio. can multiply or divide only in ratio. Have a true zero means quantity doesn't exist under only ratio scale. So that's a summary kind of. And then we move on to a very important slide. Sometimes we deal with the same variable. Let me just repeat. We deal with the same variable, and the same variable can go to different scale. Different scales. Question is, how do you measure? Let's look at education as a variable. Now, some people measure education as a type of education. Some people measure education from the level of education point of view. Some people can have number of years of education. How you measure your variable? I think there was some connectivity issue, right?
Yes, sir. Yes, sir. Please continue. Please continue.
I need to share the screen again, I think.
Please, sir.
Is it visible now?
Yes, sir. It is visible.
Yes, sir. Yes, sir.
Yeah. Okay. Just sorry for the interruption because there was some connectivity issue. Maybe from my end or from your end, I don't know. Anyhow.
No issue, sir. Please continue.
Okay. Now let's look at education as a variable. Now education can go to nominal scale when measured by the type of education, such as private or public. Some people prefer private education, some prefer public education. So it's individual choice. So your data will go to the nominal scale. The same education variable can go to the ordinal scale if you measure by the level of education, say primary school, high school, college, or postgraduate. These categories can be arranged in order. And the same variable can go to ordinal scale. What is your variable? Variable is education. And if you go to US or Europe or any other country, they will ask you about the number of years of education. 5 years of education, 10 years of education, 20 years of education. And the same variable can go to the interval scale. So question is, how do you measure your variable will determine the scale. Now, why I discuss all these scales? Because in factor analysis also, we need all these scales. And entire statistical analysis depends upon the knowledge of these scales. Sometimes we have to deal with only categorical data. Like questions are a yes, no type. Then the statistical techniques are different. Maybe you have to go for chi-square test, or maybe you have to go for test for proportions. So statistical techniques are different. Sometimes we have to go, we have the entire data which is measurable quantities, like anthropometric parameters, height, weight, BMI, skin fold thickness, chest measurement, cholesterol, etc. So they are all anthropometric parameters, all measurements. You can compute mean, as the skewness, kurtosis, percentile, decile for all this type of data. And you can compare also. But problem comes whenever there is a mixture of the two. Let's say I ask you to design a health questionnaire. Now, if you design a health questionnaire, there may be some questions which are categorical in nature, like gender could be categorical, education categories, they should be they are categorical, occupation is categorical, marital status is categorical, and there may be health questions like BMI or blood pressure or cholesterol. They are measurements. And now you want to correlate gender with blood pressure, or maybe marital status with some other parameter. So again, the statistical techniques will differ. All these statistical techniques will differ. So depending upon the knowledge of the scales, we have to apply different statistical techniques. That's why I discuss all these techniques right in the beginning. Now, with this background, let's move on to when people deal with the categorical type of data, they generally compute percentage or proportions, or they draw a bar diagram or pie charts. But look at the last paragraph. In fact, one can perform all type of statistical analysis, including correlation, regression, statistical modeling, analysis of variance, even with the categorical data. But their names are different. For example, if you are computing correlations for categorical data, then Karl-Pearson correlation coefficient, Spearman's, they are not going to work. Then we have gamma coefficient, coefficient of uncertainty, eta coefficients, then phi coefficients, Kendall's coefficient. So all these different type of correlations are there whenever we deal with categorical data. Similarly, different regression techniques are there to capture categorical data. Logistic regression, probability regression, I request each and everyone to mute, please. Can you request Dr. Sudipta?
Yes,
Dr.
yes.
S.K. Ghosh?
Already,
Yeah, there is some...
already muted, sir. Already muted.
Okay, all right, all right. And when people deal with the... So even an also variance you can do for categorical data, but these are known as Kruskal-Wallis test or Friedman test. Now, whenever we deal with the measurement kind of data, you have a lot of choices. You can compute mean, standard deviation, you can draw histogram, box plot. Please remember, for categorical data, we always draw bar diagram or pie charts, etc. But for continuous data, either we draw histogram or we draw box plot. Histogram and box plot, they are for continuous type of data, continuous measurement type of data. And what is for categorical data? The diagrams. That's why for categorical data, they are known as bar diagram, pie diagram. And whenever we talk about graph, then I'm referring to a continuous variable like histogram or a box plot. Then there are two types of tests. Maybe somebody will cover all these tests during this workshop. One type of test, they are known as parametric test. Another, they are known as non-parametric test. So if your data satisfies the assumptions, certain set of assumptions like normality, independence, etc., then we apply parametric test. If it is not being satisfied by your data, then we go for the non-parametric test. Okay. Now, before coming to the SPSS part or structure equation modeling, little bit about descriptive statistics. You need to understand, you need interpretation of the data. Why it is called descriptive statistics? Descriptive comes from how to describe the features of your data through statistics. That's why the name comes descriptive statistics. Let me give you a very simple example. Suppose there is a basket, and in a basket there are suppose 100 oranges. And I ask you to, can you comment something on this? So somebody can say some are small size, some of them are medium size, some of them are bigger size. Somebody can say they are of different colors also. Some are green, some are yellow, some are in between. What you are trying to do basically? You are trying to describe the features of oranges. Hopefully you agree with me, right? Now, these are just 100 oranges. Suppose I give you 5,000 observations. Suppose I give you 50,000 observations. Then you cannot describe like this. That's why there is an importance of statistics or mathematical measures. Statistics or mathematical measures. So the first job to describe your data is called measures of center tendency, which you have learned in your 9th or 10th standard these days. These are in terms of mean, median, mode. Everybody knows that. I'll not go into any formula, but try to give you where to use the appropriate measure of center tendency. Center tendency means how the observations are concentrated around the center and other observations are scattered around that value. The first measure is called mean. Now, how do we compute mean? We add all the observations, divide by the number of observations. If there are 20 observations, I'll add out 20, divide by 20. You will get the value of mean. But let me give you a very simple example where we face problem with mean. Suppose I give you a population data where all population figures are available from 1981 to 1990, 10 years of data. 1981 population is given, 82 population is given, and all up to 1990 populations are given. Population figures are given. And I ask you to compute what is the mean. So you will add all the 10 values, divide by 10, you will get your answer. Hopefully I am correct, right? But suppose 1988 population is missing. The population is not available. There is a question mark. Now I ask you to compute mean. You can compute mean of 9 values because they are available. But I am asking to give me the answer to the 10 values. Now your simple problem becomes difficult. Mean becomes difficult to compute whenever there are missing values. Another problem with mean. Suppose all your observations lie between 120 to 140. between 120 and 140. All observations lie between 120 to 140. Can you tell me, if I compute the mean of all this, mean will certainly lie between 120 to 140. You will agree with me, because mean is the central value. So if your values are lower values, that means they are more values towards less than 130, your mean may come out to be 125, 126. If more values towards 140, your mean may come out to be 135, 136. And if they are equally scattered, then you can get around 131 or 130. Hopefully you will agree with me, right? So, but mean will certainly lie between 120 to 140. Now, suppose there is one observation which is 280. One observation which is 280. Now, I also include this observation into computation of mean. Because of this observation, your entire mean may come out to be 170. While 99.9% of the observations, they are between 120 to 140. You are computing mean as 170. Do you think the mean is giving you a right representation of the data? Hopefully you will agree with me. Not. Then what to do? So mean is difficult to compute if there are missing values. Mean doesn't make any sense if there are outliers present in the data. 280 is an outlier. What is an outlier? Outlier is an observation which is away from the main body of the data. Your main body is between 120 to 140. In that situation, mean doesn't work. Then that's why there is importance of median. Now, how do we compute median? We arrange the data in order, then look at the middlemost value. Now look at again the same example. All observations, one observation is 280 and other observations, they are 99.9% observation between 120 to 140. Now arrange your data in order and compute median. Even if there is one observation which is 280, but your median will certainly lie between 120 to 140 because it is in the center. So median makes sense rather than mean. Look at the population data where 88 population was missing, but I know population is increasing most of the time. In India, it will never decrease. We have crossed China now, right? So I can easily assume that 88 population will be higher than 87. 89 will be higher than 88. So you can arrange the observations in order and then look for the middlemost value. So if there are 10 values, so middlemost will be mean of the 85 and 86. You take the mean, you will get the value of the median. So median is easy to compute rather than mean. Hopefully you understand what is the difference between mean and median. Where to compute mean, where to compute median. Then next is mod. What is mod? Look at the definition. The most frequently occurring value among the set of observations is called mod. Look at the series 1 data, where all the values are 1, 5, 4, 5, 5, 5, 7, 3, 5, 2. Can you tell me which value occurs most frequently? Obviously 5. So answer that most frequently occurring value is 5. So mod will be 5. Look at series 2 data. In series 2 data, 5 is occurring 5 times. 7 is also occurring 5 times. So somebody can say, what is the value of mod? Somebody can add the 2. 5 plus 7 divided by 2. Answer will be 6. And this is people give the answer. That answer is 6. Absolutely absurd and wrong. Why? Because 6 is not the most frequently occurring value. 6 doesn't even occur once. So 6 cannot be mod. So what is the correct answer? Correct answer is there are 2 mods in this data. One is 5, another is 7. Remember, mean value is always 1. Median value is always 1. But mod may not be unique. If there are 2 mods in your data, then this is called bivariate distribution. If there are 3 mods, then this is called trimodal distribution. If there is only 1 mod, then this is called unimodal. And 3 and above, they are generally known as multimodal distribution. Look at series 3 data. Look at series 3 data where no value is repeated. If no value is repeated, somebody can say that all the values can be considered as mod. No, not at all. Because look at the definition. Definition says most frequently occurring value. There is no most frequently occurring value. So correct answer is mod will not exist. Mod will not exist. That is the correct answer. So hopefully you understand the difference between mean, median, and mode. Now let me come to a very important part. Once we know the mean, median, mode, why to look into dispersion or variation, variability, right? Now look at series 1 data and series 2 data. Series 1 data is 1, 5, 9, 13, 17. Series 2 data is 7, 8, 9, 10, 11. Add the series 1 data, answer will be 45. Add the series 2 data, again answer will be 45. Both of them, they are having 5 observations. Now how do we compute mean? Sum divide by the number. 45 divided by 5. So mean will be 9 in the first case, mean will be 9 in the second case. Right? Now here is a very important question. I'll not show you the data. My simple question is, if mean of 5 observation is 9, let me just repeat. If mean of 5 observation is 9, can you make out whether this has come from series 1 or series 2? Hopefully not. It could be series 1, it could be series 2. So that, what does it mean? That means mean is not describing your data completely. There is something missing. And that missing part is basically called variability or variation, right? That's why we look into measures of dispersion. Look at series 1 data. The observations are quite apart from each other. 1, 5, 9, 13, 17. Look at series 2 data. They are very, very close. 7, 8, 9, 10, 11. Very close. So if you see from your eye, you can easily see that variation in series 2 is less as compared to data in series 1. But these are just 5 values. Suppose I give you 50 values. Suppose I give you 5,000 or 50,000 values. Then it becomes more and more difficult. That's why we look into mathematics or statistical measures. The simplest measure to look into dispersion is range. Range is nothing but the difference between highest and lowest. In the first case, the range is 17 minus 116. That is called R. In the second case, it is just 11 minus 7. Where the range is less, dispersion is less. Where the range is high, dispersion is high. But range is not a very good measure of dispersion. Why? Because it just depends upon 2 values. Just look at that example, where if all the values are between 120 to 140, what will be the range? 140 minus 120, it is just 20. But suppose one value is 280. Now you compute range. 280 minus 120, so it comes to 160. While 99.9% of the observation, they are between 120 to 140, your range showing 160. It doesn't make any sense. So range is not a very good measure of dispersion. What is the best measure of dispersion? The best measure of dispersion is either called standard deviation or it is called variance. Standard deviation or variance. Now, how do we compute this measure of variability or dispersion? So here is a very simple example. Again, it is the same data. 1, 5, 9, 13, 17. Series 2, the same data. If you add, it will be, sum will be 45. Now let's do a very simple exercise. In statistics, mean is denoted by X bar. I think we everybody knows. And any observation is denoted by Xi. Xi means ith observation. For example, if I put I is equal to 1, I is equal to 1. So you will get the first observation in series 1 as 1. X2 will be 5. X3 will be 9. X4 will be 13. And X5 will be 17. Similarly, in series 2, your X1 is 7. X2 is 8. X5 is 11. Hopefully you understand, right? Let's take very simple example. Mean is denoted by X bar. Your X bar is 9. So what I'll do, I'll subtract the mean from every observation. So in series 1, I do this exercise, Xi minus X bar. Your X bar is 9. All these are Xi values. So first value will be 1 minus 9 minus 8. Second, 5 minus 9 minus 4. Third, 9 minus 9, 0. 13 minus 9, 4. 17 minus 9, 8. Similarly, do it for series 2. So 7 minus 9 minus 2, then minus 1, 0, 1 and 2. Now why I subtracted the mean? Now you can see once you subtracted the mean, 0 has come to the center. Here it is 0, here it is also 0. And comparison in terms of 0 is very easy. Because what is the range of this difference? This difference is range is from -2 to +2, closer to 0. But what is the range here? -8 to +8, far away from 0. And the picture will look like this. This is series 2 only from -2 to +2. And what is series 1? -8 to +8. So immediately you can see that this series 1 is having more dispersion as compared to series 2. Right? So immediately you will see. But people from social sciences, people from medical sciences, they are afraid of negative sign. They always say, we have given the data to you as a positive. Now you are coming out with negative. Then statistics people are very smart. Okay, he says, no problem. Let's make your data positive again. How, if there is any data negative, how you can make it positive? You square that quantity. So let's square xi minus x bar square. So -8 square will be 64. -4 square will be 16, 0, 16 and 64. Similarly, do it here. It will be 4, 1, 0, 1 and 4. Now, nothing has happened. Only thing is you are getting rid of the negative sign. That's all. Let's go one step ahead. Suppose I take the sum of this square. Sum of this square. Sum means you add all the values. 64 plus 64 will be 128 plus 16. 128 plus 16 is 144 plus 16 is 160. So you can see sum of this square is 160. Same way you can do it for series 2. 4 plus 4, 8, 9 and 10. So it is 10. Now one thing is clear. Where this sum is less, you are arriving at some mathematical formula, you see. Where this sum is less, the dispersion is less. Where the sum is more, dispersion is more. Hopefully you will agree with me. But there are 5 values here, 5 values here. So you can compare this sum, no problem, because there are 5 values. But suppose there would have been 2 sections, section A and section B. In section A, there are 100 students. You have marks of 100 students. And in section B, you have only 40 students and you have marks of 40 students. And then you apply this technique, subtract the mean, do it, and then add. Obviously, if there are 100 observations, this sum will be more. And where there are 40 observations, sum will be less. Can you compare them? Section A and section B in terms of sum. You cannot do that. That's why we take an average. The average means you divide by n. If there are 100 values, you have to divide by 100. If there are 40 values, you will divide by 40. And you will see averages will almost be same. So we divide this sum by n and we get the formula 1 by n, summation of xi minus x bar square. So 160 divided by 5 will be 32. And here 10 divided by 5 will be 2. And this is the formula which we have learned in our 10th standard. That formula is called formula for variance. Formula for variance, right? But this is the logic behind this variance. Hopefully you understand the logic today, right? Now, what is the power here for variance? Power is 2. So we generally denote this power, which is 2, by M2. M2 stands for variance. Variance means it is a second order movement because power is 2. Power is 2. So we call this as M2. M2 means second order movement. M-O-M-E-N-T, second order movement. If I raise this power 3, that means you multiply the differences 3 times and then add. You will get M3. They are known as third order movement. And you do it with 4 power, you will get M4. That is called fourth order movement, right? So these movements like M2, M3, M4, they will help you to understand the next measure, which is called skewness and kurtosis. Now, before coming to skewness and kurtosis, once we know the variance, why we look at standard deviation? What is standard deviation? Standard deviation is nothing but under root of variance. You take the under root. Why we take under root? Once we have the measure of dispersion as a variance, why to look at standard deviation then? There is a logic again. What is that logic? Let's say I give you a height of 10 students and I ask you to compute. The height is given in centimeters. Now I ask you to compute mean. You will add all the 10 values, divide by 10, which is a constant. So your answer to mean will come out to be in centimeter. That this is the mean in centimeter. Hopefully you will agree with me. So mean, the units for mean will be centimeter. What about the units of variance? Variance is centimeter square because it's a square quantity. So units for variance will come out to be centimeter square. Now, if I ask you to compute add mean plus variance, can you do that? You cannot, because mean is centimeter, variance is centimeter square. They are in different units. You cannot add that. You cannot subtract that. That's why we look into standard deviation. If I take under root of centimeter square, you will come back to centimeter again. You will come back to centimeter again. Now, if I ask you to add mean plus standard deviation, you can do that. Mean minus standard deviation, you can do that, right? So that's why we compute standard deviation. Now, another important measure is called coefficient of variation. Let's say I'm teaching a class and there are, suppose, 30 students, and I measure their height. I also measure their weight. So weight is having 30 values, height is having 30 values. Now somebody asked me this question, whether weight is having more variation or height is having more variation. Now, even if you compute standard deviation or variance, for standard deviation, your answer will come out to be in terms of kg, kilogram, if it is weight variable. But for height, your standard deviation will give you units as centimeter. Can you compare centimeter and weight? You cannot do that. Again, there is a problem. In such type of situation, we use this, what is called coefficient of variation. We compute coefficient of variation when we want to compare different series and they are measured in different units. For example, for height, let's say, I compute standard deviation of height, which will be centimeter. I also compute mean of height, which is also centimeter. Now, what is the formula for computing coefficient of variation? Sigma by x bar. Sigma is centimeter, x bar is centimeter. Units will get cancelled, multiply by 100 will give you percentage. Suppose height percentage is coming out to be 17%. Same thing you can do it for weight. Let's say weight, again compute standard deviation kg, kilogram, x bar kg, kilogram, units will get cancelled, multiply 100. Suppose this percentage is coming out to be 37%. So for height, it is coming out to be 17%. For weight, it is coming out to be 37%. So now you can compare because they are free from units. So I can say that weight is having more variation as compared to height. So remember, coefficient of variation is useful whenever we want to compare series which are measured in different units. And the last part, median divides the data into 2 equal parts, quartiles divide the data into 4 equal parts, deciles divide the data into 10 equal parts, percentiles divide the data into 100 equal parts, and skewness and kurtosis. Then I'll move on to SPSS for 5 minutes, how to enter data in SPSS, and then the last part will be of factor analysis, which will take around 40 to 45 minutes. Skewness and kurtosis. Now, what do you mean by skewness? Skewness basically means lack of symmetry. Lack of symmetry. That means the data is not symmetrical. For example, everybody knows how to draw histogram. We divide our data into intervals, small intervals, 10 to 20, 20 to 30, and count the number of people in each interval. Then construct rectangles. On x-axis, there will be class intervals. On y-axis, there will be frequency. And the height of the rectangle will be proportional to the height of the corresponding frequency of the people in that particular interval. This is how we draw histogram, right? Now, let's say in histogram, 1 bar is here in the center. There are 3 bars on the left-hand side and 3 bars on the right-hand side. And your curve will look like this. It's symmetrical. And if you draw a line from the center, you can easily see that area on the left-hand side and area on the right-hand side will be approximately same. If this is the case, that area in the histogram, you drop a line from the highest point, and if area on the left and right, they are same, then we say that there is no skewness. Then we say that there is no skewness. All right. But let's say I look at the shape of the histogram and 1 bar is here. Then there are 2 bars on the left-hand side, but there are 9 or 10 bars, small bars on the right-hand side. And if you draw a curve will look like this. If curve will look like this, immediately you will see that if you drop a line from the center, if you drop a line from the highest point, area on the left hand side is less, but area on the right hand side is more. If this is the case, then we say that your data is positively skewed. Then we say that your data is positively skewed. And if it is other way around, if we drop a line from here, area on the right hand side is less, but left hand side becomes more, then we say that it is negatively skewed, right? So if it is symmetrical, then we say that this data is following a normal distribution. If it is positively or negatively skewed, then this type of data is not following a normal distribution. That kind of inference you can draw out of this skewness. And skewness help you to judge the type of the distribution, right? Now, how it is being measured? Beta 1. The scale is called beta 1. And beta 1, if the value of beta 1, SPSS will give you value of beta 1. This is how we compute. We compute the third order moment. Then we look at the second order moment and then apply this formula. This will give you value of beta 1. If value of beta 1 is coming out to be 0, then you are looking at symmetrical graph. Your graph will look like this. If value of beta 1 is positive, it will be positively skewed. If value of beta 1 is negative, this will be negatively skewed. Now, some of you might be wondering that under root quantity, third order moments could be negative, it could be positive. But second order square can never be negative. So square can never be negative. So M2 can never be negative. M3 could be negative or it could be. For example, if you are multiplying -1 3 times, -1 into -1 into -1. So you will get a -1. So sign of beta 1, I have written plus minus. Plus this plus or minus will depend upon the sign of M3. Under root quantity is always positive. In the under root quantity is always positive because we are squaring the third order moment. That will come to positive. This is already positive. So ratio will be positive. Then how to assign positive or negative sign? Look at the sign of M3. If sign of M3 is negative, assign negative sign here to the value. If sign of M3 is positive, assign positive sign. So either you will get value of beta 1 as positive, negative, or 0. If it is 0, symmetrical. If it is positive, positively skewed. If it is negative, negatively skewed. And the last measure is called kurtosis. Kurtosis measure the peakedness of the curve. How peak it is, how flatter it is. Right? Now look at the three shapes here. This is one type of shape, second, third. Suppose you drop a line from here. Area on the left and right, they are same. So it is symmetrical. Beta 1 will be 0. Look at this one. Again drop a line from the center. Area on the left hand side and right hand side, they are again same. Again beta 1 will be 0. Again symmetrical. But again draw a line from here, center. Again area on the left and right, they are same. If areas are same, your beta 1 will be 0. There is no skewness. But do you think the shapes are same? Shapes are different. This is having high peak. This is having flatter peak. This is having in between. So kurtosis measure the peakedness of the curve. How peak it is, how flatter it is. How do we measure? In terms of beta 2. Beta 2 is fourth order moment divided by square of the second order moment -3. If the value of beta 2 is coming out to be 0, then this type of curve is called mesokurtic or normal curve. For example, the first one. First one is mesokurtic or normal, one and the same. For this type of curve, your value of beta 2 will be 0. Right? But if beta 2 is positive, then this type of curve is called leptokurtic curve. Lepto means having high peak. So if beta 2 is greater than 0, then it is called leptokurtic. And similarly, if beta 2 is less than 0, then it is called platykurtic. Platy stands for flatter than the normal. Right? Flatter than the normal. So fully understand, in descriptive statistics, we generally compute mean, median, mode, skewness, kurtosis, percentile, decile, dispersion measures. All this is a part of descriptive statistics. They can describe your data or the different features of your data. So with this background, there is one exercise to you. There is line A, there is line B. Now, if you see from your eye, which line looks smaller, A or B? Yes, please. Anybody can answer? Dr. S.K. Ghosh. A is smaller or B is smaller if you see from your eye? Yes, please. Anyone? Any participants?
Anyone can unmute
Yeah.
yourself and respond to the faculty member.
Yes, yes, please. Anyone? Yeah, A looks smaller, but let's test your knowledge. This is your A and this is your B. So virtually A and B, they are same. A and B lines are same. But if you see from here, A looks smaller and B looks bigger. What is the difference? Difference is because A is closed from both sides and B is open from both sides. In the same way, human mind also works with the same logic. If you are listening to me with closed mind, you are looking at line A. If you are listening to me with open mind, basically you are looking at line B. You can understand so many things in a better way if you listen to me with open mind. That was the logic behind showing this diagram. Understand? Okay. So before coming to factor analysis is a multivariate technique. Let me differentiate a little bit between univariate, bivariate, and multivariate. Now, if you are given a single variable, let's say I am given only height. So I can look into different features of height. What is the mean height? What is median? What is mod? What is the 25th percentile? What is first quartile, decile, etc. So if you are referring to a single variable, then it is called univariate. But there could be two variables. Let's say I'm looking at the relationship between height and weight. Can I say that if height is increasing, weight will also increase? Or other way around, right? So you are looking relationship between two variables. Then if you are looking relationship between two variables, then this is called bivariate. Bivariate means dealing with two variables. But if you are looking into a sequence of variables, let's say yield of a crop. The yield of a crop, which is in terms of quintals, may depend upon number of factors. It may depend upon amount of fertilizer used. It may depend upon amount of seed used. It may also depend upon amount of rainfall, amount of temperature. So you are having a number of variables and you are trying to find out relationship between variables. It's more than two. If it is more than two, then this is called a multivariate technique. Hopefully you understand the difference between univariate, bivariate, and multivariate. So this factor analysis is a multivariate technique. But right in the beginning, I covered the univariate part. And sometimes I also covered like height and weight, the bivariate part in between. So now we are moving on to factor analysis. I think Dr. S.K. Ghosh, there will be some session on how to enter data in SPSS and all these things. Yes or no? There will be some session, no?
No, sir, these are the basic things. So if anyone will
Okay,
discuss from the basic things, so they can.
Okay. So I am presuming that everybody knows about SPSS. And if you don't know anything about SPSS, just in 1 or 2 minutes before coming to SPSS, I'll explain you how to enter data in SPSS. So this is the logo for SPSS. This is called IBM SPSS Statistics. And if you click here, you will come to the worksheet of SPSS. And in the worksheet of SPSS, it is just like an Excel worksheet. I'll tell you certain things. So how to enter data in SPSS, give me 5 minutes, then in 40 minutes, I'll be able to complete the factor analysis part. Okay, all right. So this is your screen. Is the screen visible? Yes, please.
Yes, sir, it is visible.
Yes, sir, visible. Yes, sir, visible.
Okay. Now question is how to enter the data in SPSS. So this screen is very much similar to Excel. In Excel, only thing is you have ABCD here in Excel. But here you have variable. That means you can enter different variables. Similarly, on this side in Excel, you will have sheet 1, sheet 2, sheet 3. But here there are only two. One is called data view. Another is called variable view. Whatever you are observing is a data view. So there are two ways to enter the data in SPSS. One is you can directly enter the data in SPSS just like in Excel we do. So how we do that? Suppose I enter some data. Right? So randomly I enter few observations, these. So I entered 11 values. So by default, it has given some variable name. I have not given any variable name. But let's say this is the age of patients or age of students. Students cannot be 77 years. So that's age of patients. Okay. So go to the variable view and change its name. Suppose I change this name to age. So you can write this age and come back to the data view. Your actual name is appearing. Similarly, you can enter marks of the students. You can enter height, weight, blood pressure, etc. Now I started with 2344. Once you start with any numeric value, SPSS automatically understand that this is a numeric data. SPSS automatically understand that this is a numeric variable. You can see I have not given any type, but it has understand that type is numeric. But suppose I want to enter the name or address or anything which is not numeric, like employee code EMP002, then it is alphanumeric. Then SPSS automatically understand that this is not numeric. For example, let's say first one is a male. So it is accepting. Second one is a female. Now it is not accepting. Why it is not accepting? Because if you go to the variable view, this variable, which is not numeric, is called a string variable. And the width of a numeric variable was 8. What is the width of a string variable? Only 4. So male has 4 words. That's why it is accepting male, M-A-L-E. But female has 6 words. So that's why it stopped at 4, F-E-M-A. But you can always increase. You click here, so you can increase this. You can also make this 8. You can decrease also. You can, if you want to enter address, you can straight away write here 80. And you can write the complete address. No problem with this. Let's say I make this 8, go to the data view, and then again go to female, F-E-M-A-L-E. Now it will accept because you have increased the width. Right? This is how you can enter. Now the problem is, if I give you, let's say 5,000 observations to enter, and in front of every time you need to write male, female, it's a very cumbersome job. But you can always choose a code. Let's say male as 1, female as 2. So let me write male as 1, female as 2. So somewhere there will be 2, somewhere there will be 1, something like this. Right? 1 stands for male and 2 stands for female. But how SPSS will come to know that 1 is male and 2 is female? So that is the important feature of SPSS. You go to the variable view and then you can, this is variable number 3, go straight away, go to values and give the labels. So 1 is, let's say male. 2 is female. 2 is female. So you come back and you come back to the data view. You can see 1 is replaced with male and 2 is replaced with female. So job becomes easy. Just you need to enter 1 and 2, right? Then to remove, I don't require now variable number 2. So how to delete this? You do not press here. Always press at the border, this border, top. Then this column will become yellow. Then right click and cut or clear, whatever you want. Or you can press delete from your computer screen, right? From the dashboard. So it will go out of the picture. So this variable, I can name this as gender. This is gender. Now you can do preliminary analysis. For example, if I want the frequencies, let's say frequency. So you can count frequency for gender. So it will give you the answer that how many, there are 5 males, 6 females. You can get answer. Similarly, if I want mean SD, etc., then go to analysis, descriptive statistics. In descriptives, let's say I take this age here, and options, I compute, let's say skewness, kurtosis, mean, etc. All these values. And then press continue and press OK. Then you can see the mean is computed, minimum value is computed, maximum value is computed. So all the answers you will get. So immediately you will get answer to your questions. But I don't have a time to discuss all this. If you are serious in learning SPSS, you can go through my video. So please note down those who are having pen or pencil. On any search engine like Google or whatever, you can write statistical techniques using SPSS. Statistical techniques using SPSS by Suresh K. Sharma. Statistical techniques, let me just repeat, statistical techniques using SPSS by Suresh K. Sharma. Right? Now then YouTube video will open. This is 1.5 hour video. and you can learn SPSS. You can learn SPSS even with the pause and move forward and backward. You can learn all the commands related to SPSS. That will make your task easy, right? So for the time being, I'm just stopping here. I'll move on to factor analysis as time is not permitting to go beyond this. So now you have a little bit idea about SPSS. How to save the file? Go to File, go to Save As, and let's say I want to save this on desktop. You click on to desktop, give the file name. Let's say this is demo, and then you press Save. And once you press Save, then a file on the desktop will appear with the name as demo SAV. For example, this is an SPSS file, table SAV. This is already on desktop. US data SAV. It's already. So just like you can recognize Excel file, you can recognize Word file, you can also recognize SPSS file. SPSS file is having extension as SAV. So you can save and then you can open it. It will open only if you are having the software. Otherwise, it won't open. So with this background, let me move on to. So I have saved certain files already. And without wasting further time, we are left with about 40. Yes, please.
Sir, we will
Yes.
take a 5 minutes of break because you are transferring from one topic to another topic. So I am taking permission from you that Professor V.K. Malhotra, Association President, Indian Economic Association, just joined with us. He was in a meeting. That's why he was unable to join in the inaugural session. So I will take 5 minutes of time from your end, and
No problem.
I will request Professor V.K. Malhotra, sir. So please address our participants. Sir, can you please turn off your share?
I'll stop sharing.
Yes,
You can share your screen. I'll stop sharing.
Yes, sir. Please continue. Welcome you, sir.
For FDP.
Yes.
Yeah, now you can continue.
Yes, sir. You can continue. We can.
Yeah, we can hear you,
sir. Please continue, sir.
I hope you can hear me.
Yes, sir.
Yes.
Okay. Thank you, Dr. Subrat Ghosh. In fact, I'm very happy to join you all, and Professor Anirban Sarkar had spoken to me about this faculty development program being organized by Bharatiya Vidya Bhavan Institute of Management Science. And I think it's in collaboration with Indian Economic Association. So hopefully some members of the organization must have joined, and since I could not join in the beginning itself of this program, because we had some meeting at Niti Ayog, and I just came running from there. And joining any program like this, I mean, because Subrat did ask me to join while traveling from Delhi to my place. In fact, in joining on phone is reflective of one's non-seriousness. In fact, in such program, I could see that you have collaborated with SPSS South Asia Private Limited also. So it's a good beginning that 3 organizations, 3 institutions are joining hands, in fact, to impart skill training to the budding, hopefully managers of the future. If I'm correct, you may correct me also, because I don't have much idea of the background.
So this is for the faculty and research scholars.
That's right. Right, budding managers and faculty is meant for that, to help them grow, to help them flourish, in fact. And again, I'm very happy to see most of the FDPs, they happen to end with discussing general things. And basically, whether you talk of management science or you talk of economics, or now the world is changing, you talk of even social science, skilling people or upskilling people is definitely one of the primary objectives of every important training program, whether in India or in the world. Of course, when we go through NEP 2020, we do notice that there is a strong realization somewhere that perhaps we have not been able to impart the skill training corresponding to one's degree, in fact. And this is what makes a big chunk of the degree holders in the country unemployable, in fact, in a true sense of the word. If we really intend to promote, because imparting good training, making the upcoming generation better skilled and more employable, I think is the key to success, and it definitely offers a win-win situation to all of us. In the sense, institutions exist for imparting such kind of training, and definitely upskilling, improving, and enhancing the human resources existing in a country. It's a very, and if you go through the works of the recent Nobel laureates also in economics, you would notice one thing is very commonly visible, which is that somewhere, even in advanced countries now, people's time lag in upskilling their population, in their upskilling their human resources, to the extent of technology shift taking place in the world, is definitely somewhere convincing us that the lots have become slightly unemployable even in developed economies of the world. So the challenge to a developing economy like India is definitely far more greater, in the sense that we have a vast population, and a big chunk of that, 50 to 60% of that vast population, needs a gainful employment also. And they have to take, we are coming to a realization that mere public sector cannot serve the interests of the economy. It has to be essentially in a framework of public-private partnership. When we say that 92% of the employment lies in unorganized sector, we are perhaps trying to say that this 92% has to be upskilled in a sense that they can, not only unorganized sector can take care of them, they can also take care of their own selves. But that's possible only when we are equipping them with the best possible training that we can. I'm very happy to notice, I remember long back when we had started with our own researches, we started to make use of techniques like SPSS. I remember those days also when professors used to go to the technical hands, when computers were quite new in this country. They used to go to the technical people, request them to write programs to solve their research issues. As managers, as entrepreneurs, as economists, and as concerned citizens also, we are all concerned with, or we are all concerned about estimating the things, perhaps forecasting the things if our estimates are based on sound logic and rationales. It is in this interest that a good training, especially training in, there are 2-3 major components of any training in a statistical sense. Data collection is definitely one major way, and I know that repeatedly we have felt that certain data collecting agencies and data collecting methods in this country, they need to be upgraded, they need to be further strengthened, and in several areas where data collection is still not existing, their data collection has to be in place, in fact. And post data collection, of course, we are required to conduct analysis, and this analysis must equip us that how to run several, let's say, programs or such kind of programs which would help us to analyze the data which is available, because we all understand sometimes data can be too raw. And secondly, data can be analyzed in various ways also. So what are those ways to analyze the data and reach at a very sound logic or reasoning behind the cause and effect relationship? And since this program is about multivariate data analysis, so I'm sure that the budding scholars, the budding managers, they would understand. And it's good, especially when it comes from a management institute, because as I said, that most of us are interested in estimating the things much in advance before they happens. So it's all about that, because everybody wants to, you talk of political arena, there also people are interested in guessing that who is going to win what number of seats and on what factor it is going to finally depend on. So is the case with the factors that we have in the market also. We have a given demand. We have a given growth rate of demand. We have given number of industry and players in the market also, tastes and preferences, people's income. And on that basis, we intend to definitely estimate the demand relating to a particular industry or a particular firm also. So I'm very, very sure the kind of training, and I could see Dr. Sharma was making his presentation. I'm sorry to have definitely interfered in his presentation in the middle of it. And over 5 minutes, whatever I could hear was that he was definitely trying to make point, and he was trying to inform the students that how these techniques have to be used, how on YouTube they could find the videos also, through which also they could learn. I'm sure that such even online programs would definitely not only upskill the students or the scholars and the young faculty, they would also, if they face any problem, they would also respond to the queries in their mind. They would also solve their question. And now we have techniques, of course, where each one's screen can be very closely monitored also. So I'm sure you would be doing all that. And experts like Dr. Sharma will definitely leave a very deep impact on the student, their skills, because as I said in the beginning, there is a lot of realization that mismatch between degree and skill levels in the country, it has to be somehow removed. And such programs would be a great help because imparting right kind of education and skill is serving the society, despite the fact some institute or some institution might have slightly a commercial approach also. So as I said, that public-private partnership and private is not to be or is untouchable in some way or the other. That's no longer holds good in this country's life. So I'm very, very sure that this program and the participants of this program would definitely be gaining a lot. And I'm sure that all sessions will be conducted in a very open, frank, transparent, and very receptive manner. I wish this program a very big success. Thank you for making me join and bearing with me my tight schedule also. Thank you.
Thank you, sir. Thank you very much for your insightful delivery. and I am really thankful to Indian Economic Association for their wholehearted support. Thank you, sir. And we have with us our principal from Bharatiya Vidya Institute of Management Science, Dr. Shiva Prasad Mahapatra. Sir, would you like to say something?
And
Warm greetings to
I
you.
could see his face also, but I didn't know his designation, in fact. So
Yes.
my hello to Dr. Mahapatra.
Dr.
Right.
Mahapatra is the principal of Bharatiya Vidya Institute of
Very
Management
good,
Science.
very good, very good. Whenever I get a chance to visit Kolkata, I would definitely love to see you all and have a cup of tea with all of you.
Sure.
This time your tea stand saved, but next time, be clear.
That will be a pleasure to host you at Bharatiya Vidya Institute of Management Science, Kolkata.
Right.
We are so humble and grateful to you for your association for this great event, where you rightly said we are imparting training, skills, and promoting research in a big way, as it's the need of the hour, sir. Thank you for supporting us in this.
Thank you. Thank you.
Thank you, sir.
Now it's on to Dr. Sharma. Sir, I also know that this is a slight interruption, but Dr. Malhotra, sir, we just wanted to have his view on this program. So I hope now onward you can continue.
Thank you. Thank you.
Okay, thank you very much.
Thank you.
And Professor V.K. Malhotra has made a very valuable points, in fact, and given a very insight of education, new National Education Policy 2020, what the next is coming to be useful for the participants and the young generations. So I will start from where I left. I will start with the factor analysis and try to cover that part.
Thank
All
you.
right, let me share the screen.
Thank you.
Hopefully the screen is visible again.
Yes, sir. Yes, sir.
All right.
Yes, sir, visible.
Yeah. So quickly, let me go through a little bit of theory of factor analysis, and then I'll give you a practical demonstration how to do the factor analysis. Since time is very less, so it's just 20-25 minutes. So I'll try to cover factor analysis. Don't worry at all. Now, factor analysis is basically a class of procedures primarily used for data reduction or summarization. So it's a data reduction technique. So I'll give you one example that will clarify why we need factor analysis. Now, in regression analysis, if you remember, there is dependent variable, there are independent variables, and you are trying to find out the relationship between them. But there is no such thing like in factor analysis. All the variables are taken at one platform. So that's why it is called interdependence technique. Interdependence technique. We are just looking into certain relationship among variables. So there is no question of dependent or independent variable as far as factor analysis technique is concerned. Now, factor analysis is used in the following circumstances: to identify the underlying dimensions, to identify the underlying factors, or sometimes also called the latent variable that explains the correlation among the set of variables, and to reduce your entire data set into certain dimensions. And those dimensions are generally useful to carry out further statistical calculations, and they are used in multiple regression, they are used in discriminant analysis. So I'll take up one example to clarify why we need factor analysis. So if you concentrate on one example, you will be able to understand the crux of factor analysis. So here is the example. It's an era of mall. People go to mall and they want to see many things in mall, about their cleanliness, about their entertainment facilities, about their parking space, whether there are games for children, whether there is a food court. So many things people are looking into. There are big malls in the country. In Calcutta, there are obviously very big malls, in Delhi, in Chandigarh. So let's say the owner of the mall hire a team of researchers like you and give them this task, that how I can improve upon the facilities available in my mall. And this team of researchers design a questionnaire. And this questionnaire is designed based on certain dimensions. So first dimension is cleanliness. So they include 15 variables related to cleanliness. Cleanliness of ramps, cleanliness of floors, cleanliness of toilets, lifts, and so on. So 15 variables are related with cleanliness. Then obviously, if you go to a big mall, there are many movies which are playing over there, entertainment, right? For example, there are English movies, there are Hindi movies, there are movies from other languages too. So right up to 16 to 35, 20 variables, they are related to entertainment part. Then obviously, nobody would like to go to mall which is having no parking space. There are big malls. One of the mall in Chandigarh is called Elante Mall, which is having a parking of about 2,700 cars only in the basement. So obviously, you would like to go to that mall where there is enough parking space. People can. Then there are 15 questions related to parking. There is hourly parking. There is 2-hourly parking, whole day parking, right? So 15 questions related to different parking variables. Then games for children. People are playing. They take their children along. Then there are digital games, computerized games, other physical games. So 25 questions are related to games for children. And there are different brands. Obviously, it's a big mall, so there may be different brands available. 25 questions, they are relating to different brands from 76 to variable number 100. And food court. If you are going to a mall, obviously, you would like to eat for a lunch or a dinner. And 20 variables. There may be Sagar Ratna, there may be McDonald's, there may be Hot Millions, there may be any other, Punjabi Dhaba also. So 20 questions are related to food court. So in all and all, this team of researchers has designed a questionnaire which are having 120 questions. Now here is a very important point, which you can see in the bracket. Based on your observation, based on your judgment, based on your perception, you have designed a questionnaire which is having 120 questions. And the important point is, do you think that all the 120 questions will be important? That's a question mark. May or may not be. Hopefully you will agree with me. So how to find out the importance of different variables? That is the job of factor analysis. How you can, let's say out of the 120, only 20 variables are important. Rest of them are not important. Then why to look into 105 rest of them? They can be ignored. You have to just focus on just 20 important. Maybe out of the 20, 2 are related to cleanliness out of 15. 3 are related to entertainment, and so on. So these are called factors. 2 factors are coming out. 2 variables are coming out to be from cleanliness. That is one factor. 3 variables are coming out to be from entertainment. That is another factor. So reducing them into different factors. And those factors are just important, right? So how we extract these factors, right? So there is a concept in mathematics that is called linear combination of variables. What do you mean by linear combination? Suppose I take 2 variables, x1 and x2. Then linear combination of this is denoted by a1 x1 plus a2 x2. These are generally called weights. A1 is a weight, a2 is a weight. If there is a third variable also, so I can add a3 x3. If there is a fourth, I can add a4 x4. This is what do you mean by linear combination of variables. Now, if there are only 2 variables, suppose a2 is 0.8, a1 is 0.13. So where the weight is high, that means in that case, you will immediately see that x2 is more important than x1. This is how we look at the importance of different kind of variables. If more weight is attached, this variable becomes more important. If less weight is attached, then this variable becomes less important, right? Now, how these factors are extracted? How these factors are extracted? These factors are extracted. Please try to listen to me. Just concentrate for 5-6 minutes. I'll explain you this example, then you will be through with the entire technique of factor analysis. Now, there are 120 questions. There will be variation present in the data. So total variation present in the data. And total variation is present, split up into different components. These components are called factors, right? Component, factor, they are one and the same thing in factor analysis. Sometimes also called, factor is also called a latent variable, right? Now, factor analysis reduces them to manageable number of factors or components, which explains the maximum variation present in the data. What does this mean? So what is this factor analysis? It is based on a statistical techniques, which is called principal component analysis. In short, it is called PCA, principal component analysis. What is that principal component analysis? Out of the 120 variables, where all the variation is present in the data, it looks into a linear combination of certain variables. Like this is one of the linear combination. It's look into the linear combination of certain variables, which explains the maximum variation present in the data. So that is called first principal component or the first factor. So out of the 120, listen to me, out of the 120, it just forms certain linear combination of variables, which explains the maximum variation present in the data. Suppose it extract factor one, and let's say it involves only 10 variables. The 2 variables are coming from cleanliness, 3 variables are coming from entertainment, 3 variables are coming from parking space, and so on. So the first factor is having 10 variables, and let's say these 10 variables, they are explaining 45% of the variation present in the entire data set. So we call this as F1. Your F1 may be A1 V3, A2 V9 plus A3 V18, something like this. But it contains 10 variables, and these 10 variables, they explain 45% of the variation present in the entire data set. So this is called F1. So F1 is nothing but a linear combination of variables, and there are 10 variables, and these 10 variables, they are explaining 40. This is just an example. These 10 variables are explaining how much percentage? 45% of the variation present in the data set. Now, out of the 120, 10 are already under factor 1. Now, how many are left? 120 minus 10. You are left with 110 now. Now, again, it looks into the linear combination of 110 and come out with factor number 2. That is called F2. It's again looking into certain linear combination of variables out of the 110. This time, some variable may be from 51 to 75, some may be from 76 to 100, some may be from this. And let's say this time there are 8 variables, and this factor number 2 is explaining 30% of the variation present in the data. So F1 is explaining 45% of the variation present in the data. F2 is explaining 35% of the variation, 30% variation present in the data. First factor is having 10 variables, second factor is having 8 variables. So in all and all, 10 plus 8, 18 variables in F1 and F2. Now 120 minus 18, you are left with 102. Again, it reiterates the same procedure. It looks into the linear combination of rest of the 102 variables, come out with factor number 3. Let's say this time it comes out with only 7 variables, and they are explaining 15% of the variation present in the data. And that is factor number 3. Now, those variables which are there in factor 1, they are not in factor 2, they are not in factor 3. That's why they are independent. So factor 1 is uncorrelated with factor 2. Factor 3 is uncorrelated with factor 2 as well as with factor 1. Now, first factor is having 10 variables explaining 45% of the variation present in the data. Second factor, 8 variables explaining 40% variation present in the data. Both of them, they explain 45 plus 30, 75%. And the third one, 15%, 7 variables. So 10 plus 8 plus 7, 25 variables. They are explaining how much percentage of the variation? 90% of the variation present in the entire data set. Hopefully you will agree with me. That means 120 minus 25, 95% of the variables, they are explaining how much percentage of the variation? Only 10%. They can be ignored. Right? So you are left, you are reducing your dimensionality from 120 to just 25. That's why factor analysis is called a dimension reduction technique. Now, how these factors are extracted? They are based on mathematical principle of PCA, principal component analysis, and it will go on extracting factors. It will extract F4 also, it will extract F5 also, F6, F7, F9. It will go on doing this exercise. But which factors will be important? That's a question. Which factors are more important? Only there is a concept which is called eigenvalue. So for each factor, there will be eigenvalue. Let's say eigenvalue of factor 1 is 3.9. So it is more than 1. If eigenvalue is more than 1, then that factor is important. Let's say eigenvalue of factor 2 is 2.3. So it is again more than 1. So this is also important. Let's say eigenvalue of factor number 3 is 1.9. Again, it is more than 1. So again, this is important. But eigenvalue of F4, factor number 4, is suppose 0.84. Eigenvalue of F5 is 0.73. And rest of them are less than 0.1. So wherever it is less than 1, just ignore those factors. They are not important. Only pick up those variables, they are under factor 1, factor 2, factor 3, because these factors are having eigenvalue more than 1. So you have to extract only those factors will be important whose eigenvalues will be more than 1. This is how we do the factor analysis. So hopefully this makes sense to you, although I have explained quickly. But let me go through some other statistics which you will get once you do the factor analysis. So this is a factor analysis model. Put I is equal to 1. You will get factor number 1. It's a linear combination of certain variable with weights. Put I is equal to, you will get the second factor. Put I is equal to 3, you will get the third factor. But remember, only those factors will be important whose, for each factor, SPSS will give you eigenvalue. That eigenvalue of factor 1 is this. Eigenvalue of factor 2 is this. Only those factors will be important whose eigenvalue will be more than 1. Right? So K is the number of variables, Wi is the weight, and Fi is the factor extracted. So how to perform this? It is possible to select weights or factor coefficients so that the first factor explains the largest portion of the total variance, like 45%. Then the second set of weights can be selected. That explains the second largest of the residual. Residual means out of the remaining. It could be 30%. And the same principle can be applied for the rest of the factors for extraction. There are certain things which you need to understand in factor analysis. If there is certain data set, can I apply factor analysis to this data or not? There are two important tests. What are these tests? The first test is called Bartlett test of specificity. Remember, factor analysis technique is applicable only when variables are correlated among themselves. You can write down, please. Factor analysis technique is applicable only when variables are correlated among themselves. So this Bartlett test of specificity tests the correlation, whether variables are correlated or not. So hypothesis will be like this. Variables, there is no correlation among variables. That is your H0. Alternative will be that variables are correlated. So you want H0 to be rejected. When H0 will be rejected, if your p-value will be less than 0.05. So in Bartlett test, whenever the output will appear, must check that your p-value must be less than 0.05. If it is, then the variables are correlated. You can go ahead with the factor analysis. So that is the first test. Second test is called KMO test, generally called Kaiser-Meyer-Olkin test. KMO test. It is basically measure the sampling adequacy, whether your sample size is appropriate to perform factor analysis or not. And this KMO value must lie between 0.5 to 1 or half to 1. I'm not saying 0.05, I'm saying half to 1. That means 0.5 to 1. If the value of KMO is between 0.5 to 1, then that means your sample size is adequate to perform factor analysis. These are the two important tests. One will check whether the variables are correlated or not, Bartlett test. Another will check whether your sample size is adequate to perform factor analysis or not. That is called KMO test. So remember, KMO value must be between 0.5 to 1. Here it is written 0.5 to 1. And this value, Bartlett test, must be significant. So remember these two tests. It will appear. Another important statistics which will be there is called commonality. Commonality is nothing but amount of variation one variable shares with all other variables. Suppose there are 10 variables, V1, V2, V10. Commonality of V1 is 0.73. Commonality of V2 . Okay. Factor loading are nothing but weights. They are W1, W2, W2. Then you will also get the factor loading plots. I'll explain you. Then you will also get the factor matrix. Factor matrix contains the correlation among variables. Then factor scores. For each factor, you can compute scores because let's say only two variables are there. So A1 and A2. So A1 and A2 will be provided to you by the data. If you know A1 and A2, you can put the value of an X1 and X2, you will get F1. That is called factor score. Then percentage of the variance. That first factor explains this much variation. Second factor explains this much variation, and so on. You will also get the residual. Residual are nothing but the differences between the observed correlation and the predicted correlations predicted by the model. Now, just like histogram or box plot, there is important plot in factor analysis. That will give you a clear picture, and that is called scree plot. What is that scree plot? It will place your factors along x-axis, F1, F2, F3, F4, F5, and eigenvalues along y-axis. Eigenvalues along y-axis. And then you can see which factors are more important. Then you can drop a line against one. If you drop a line against one, then only those factors will be important whose eigenvalue is more than 1. If they are below 1, you can leave them. I'll show you the diagram of scree plot. Then correlation matrix will be there. Now, in principal component analysis, we generally apply principal component analysis. All the factors extracted, they will be uncorrelated with each other. F1 will be uncorrelated with F2. F3 will be uncorrelated with F1 and F2. If there is F4 also, it will be uncorrelated with F3, F2, and F1, and so on. So that type of technique is called principal component analysis because it is based on a principle of orthogonality. Orthogonality means orthogonal rotation. So if one factor is on x-axis, another factor is on y-axis, they are at 90 degrees, you can say there is no correlation. But how this is being maintained? So there is a procedure of rotation of matrix. That procedure is called Varimax procedure. Please remember, we have to use a Varimax method. Varimax method is an orthogonal rotation. We have to apply Varimax method. Then sometimes people have a prior knowledge that I want to extract 5 factors or 4 factors. Then you can put those 4 or 5 factors. They will be extracted. But let the data speak. Better way is data speak. How many factors can be extracted? They are based on eigenvalue. So only those factors will be important whose eigenvalue will be more than 1. So determinations is generally based on eigenvalues. So as I mentioned, that Varimax procedure is an orthogonal rotation. It's written here, orthogonal rotation. So we apply this Varimax procedure so that F1 is uncorrelated to F2. Oblique rotation is also there. Other rotations are also there. Generally, they are not used in factor analysis. They are meant for some other purpose. So this is the example of a scree plot. You can see this is factor number 1, factor number 2, component of the factor 1 and the same thing. Factor 4. So if you drop a line here, horizontal line, so this factor and this factor, these two factors are important. They are not. 3, 4, 5, they are not because their eigenvalue is less than 1. So only 2 factors are important. So now I'll go for the practical demo in next 5 minutes and then we will stop. So first thing is we have to look for the commonality in factor analysis. So generally commonality is required is 0.5. For each variable should have commonality 0.5 or more. That means at least 50% of the variation it should share with the rest of the variables. If it is less than that, you can drop that variable. Low loadings, you have to check loadings, whether there are low loading variables can be dropped. Cross loading, sometimes one variable can go to factor number 1, factor number 2 also. So you need to check that also. And for each factor, you have to look into the internal consistency of the data. That is through Cronbach alpha. Cronbach alpha is an reliability measure, which is called measure of internal consistency. For each factor extracted, how many variables are there? For those variables, you compute Cronbach alpha. And Cronbach alpha value must be more than 0.7. So now I'll go for the technique of factor analysis in next 5 minutes, and I'll give you the entire interpretation. Okay. So let me take up one example. How you can apply factor analysis. So I have already one of the data sheet here. So I'll take up this example. Just wait for 5 minutes, then it will be over. File is opening, just bear with me. Okay, so this is an example related to customer satisfaction whenever they buy toothpaste. So here is an example of factor analysis. The first question has been asked from the customers: important to buy toothpaste that prevent cavities. Do you think it is important that I should buy that paste which should prevent cavities? Obviously, people would like it. If it is important, then he will give this as number 7. It's a 7-point scale. For example, for first customer, it is very important point that prevent cavities. But look at customer number 2. He says no. Maybe his preference is something else. His preference is 1. He says no, this is not important for me. Preventing cavities. Maybe he's looking for shining teeth. Maybe he's looking for attractive teeth. Something like that, right? So this is how the data is being captured. For variable number 1, variable number 2, I like toothpaste that gives shining teeth. That is variable number 2. I like toothpaste that strengthens gums. V3. I prefer toothpaste that freshens breath. Variable number 4. Tooth decay benefits, that my tooth should not decay in the long run. Variable number 5. And buying a toothpaste for attractive teeth. Variable number 6. So they have been all measured on 7-point scale, and the entire data is captured here in terms of these 7-point scales. And you can see there are variables. Now we want to apply factor analysis to this, right? So let me go through the analysis. Please try to understand, note down the steps how to perform factor analysis. Analysis, then go to data reduction, because factor analysis is a data reduction technique. Go to factor. And in factor, there is no concept of independent and dependent variable. Simply press Ctrl A and take all the variables to the right hand side. Take all the variables to the right hand side. You can stretch a little bit here to see it more clearly. Right. Then what you need to click, very important, go to descriptives. And in descriptives, you must click on to univariate descriptives. Then you click on to coefficients. This is a correlation coefficients, because factor analysis technique is applicable where correlations are high. Reproduced correlations, significance levels, significance of correlation coefficient. And the most important is KMO and Bartlett. KMO, remember KMO value has to be between 0.5 to 1, and Bartlett test of specificity must be significant. So its p-value must be less than 0.05. So these are the two important tests. Continue. Then go to extraction. If you remember, extraction is by principal component analysis. By default, it is on principal. There are other extraction principles also. Oblique rotation, unweighted least squares, maximum likelihood, but only principal component is required for factor analysis. Scree plot the graph. Now, I don't know how many factors can be extracted. So let the data come out, how many factors can be extracted. So it will extract automatically those factors you can see extract eigenvalue or those factors based on the eigenvalues whose eigenvalue is greater than 1. So automatically it will extract only those factors whose eigenvalue is more than 1. Continue. Then go to rotation. If you remember, I explained that rotation method we will use Varimax, if you remember. So there are different rotations, but I will prefer Varimax procedure because it is orthogonal rotation, right? You can also click on to loading plots. That's all. 2 things here. Continue. Now go to scores. You can click on to score variables. Scores are nothing but factor scores, F1, F2, etc. And you can continue from here. And the last part of factor analysis is options. You go to options, very important. Now, I don't know, suppose in factor number 1, you have A1, A2, A3, A4, A5, suppose up to 10. If you sort it by size, you have to locate which is having highest coefficient. Maybe variable number 8 is having highest, or variable number 7. You have to locate it. But if you sort it by size, then only the first variable which is having the highest weight will appear number 1. The next one will appear at number 2. So always give this command, sorted by size. And generally we require those variables which are having high press small coefficients which are generally less than 30%. So I take 0.3. This is just a subjective. If the large data set, you can take up to 0.4 or 0.45, not beyond that, right? So it is subjective because generally we require variables which are having high commonalities. So I'm just taking, because small data set, so I'm taking 0.3. Continue. Now your factor analysis, all the points are over. I'll just go for the interpretation. Please try to learn because interpretation is more important. So press OK, you will get the entire results. So press OK and you will get the result. So here is the result. First of all, it is coming out with, let me just remove the notes from here. That will ease out certain cut and active data sheet so that you can see clearly. First is just a mean SD table for variable number 1, variable number 2, variable number 3, and so on. Then after that, you can see correlation matrix. Some correlations are high. For example, correlation between variable number 1 and variable number 3 is 0.873. Then variable number 5 and variable number 1 is 0.858. Similarly, variable number 2 and variable number 4, variable number 3. So variable number 4, it's 0.572, then 0.858, 0.77. So some correlations are high. Here it is also 0.6. So you can see based on this correlation matrix, you will get some idea that we can apply factor analysis. But the best way, rather than looking for correlation matrix, is to go for KMO and Bartlett. That will give you a very clear picture. So here is KMO and Bartlett. So first test is KMO. KMO test, Kaiser-Meyer-Olkin test, says that your value of KMO is 0.660. It has to be between 0.5 to 1. So that means the first test is satisfied. It is been. If your KMO value would have been 0.23, stop. You cannot apply factor analysis to your data. If it is below 0.5, let's say 0.38, please stop. Do not apply factor analysis. So that is the first thing. Then Bartlett test of specificity, as I explained, this is a p-value. Wherever in SPSS it is written significance, so this is called p-value. So here p-value must be less than 0.05. So this p-value is 0.000. It is less than 0.05. 0.00 is less than 0.05. So what was H0? Variables are uncorrelated. The variables were uncorrelated, yes. Alternative, variables are correlated. So it says, yes, your variables are correlated, and we can see from the correlation also. So both the tests are satisfied. If any 72.3% of the variation with the rest of the other 5 variables, and so on. This is what we mean by commonality. Now, here is the most important table of factor analysis. These are the eigenvalues. These are your factors, component of the factor one and the same thing. How many factors can be extracted? As many as the number of variables. So there were 6 variables, 6 factors have been extracted, but only those factors will be important which are having eigenvalue more than 1. So eigenvalue of factor 1 is 2.73, more than 1. And this explains 45.5% of the variation present in the data. Next, factor number 2, eigenvalue 2.218. This explains 36.9% of the variation. Total is 82. Almost 83%. Almost 83% of the variation by these 2 factors. Factor number 1, factor number 2. Look at factor number 3. Eigenvalue becomes less than 1. Eigenvalue, next one, less than 1, less than 1. So these factors are not important for me. So only 2 factors are important. And that picture is clear from the scree plot. Here, these are components. This is a scree plot. So if you double click here, if you double click and mark here, and let me go for, let's say, options. In options, y-axis reference line. Suppose y-axis reference line, I place this at 1 o'clock, 1.0, 1 point, okay, 1. Now it is shifted to 1. So you can see now the clear picture. These are the 2 important factors, factor number 1, factor number 2, which are having eigenvalue more than 1. These are not important. So I'll leave this part, right? Now, don't see this component matrix, please. This is a very confusing matrix in SPSS. Always see the rotated component matrix, which is coming after rotation. Now, what is coming after rotation is this one. This is rotated component matrix. This is after rotation. And if you remember, we have sorted by size. So it will give you which is having the highest weight at number 1. For example, 0.962. That is variable number 1 has been given the highest weightage. After that, variable number 3. After that, variable number 5. So they are under factor number 1. These are the variables under factor number 1. Because this doesn't make you clear which variables are under factor number 1. It says there is factor 1 and factor 2. These 2 factors are having eigenvalue more than 1. Now, under factor number 1, which are the variables? These 3 variables are under factor number 1. And these 3 variables are under factor number 2. It says the highest weightage is for V6, next is for V4, next is for V2. Now, look at factor number 1. This is having V1, V3, and V5. Factor number 2. This is having V6, V4, V2. Now let's look at the nature of these factors. What are this? This is factor number 1. This is factor number 2. Let's look at the nature of the variables which are under these factors. Now read. Important to buy toothpaste that prevent cavities. So this variable is related to health of the teeth. Hopefully you will agree with me. Next. The toothpaste should strengthen gums. It is also related with the health of the teeth. Third one, tooth decay benefit offered by the toothpaste. This is also related with the health of the teeth. So all the 3 variables are related to health of the teeth. So you have to give the name to this factor. So I can call this variable, I can call this factor as health benefit factor. I can call this variable as health benefit factor. So that is factor number 1. Please remember, SPSS will not assign its name. You have to assign yourself. So this is health benefit factor. Let's look at the nature of the variables under factor number 2. This says buying a toothpaste for attractive teeth. Something like cosmetic. Toothpaste that freshens breath. Again, cosmetic. I like toothpaste that gives shining teeth. Again, cosmetic or social. So you can call this factor as social benefit factor, or you can call this as cosmetic benefit factor. So 2 factors have been extracted. You have to give the name. One is health benefit factor. Another is cosmetic factor. And where you will study, somebody will teach you a structure equation modeling. He will pick up from there. Whatever the factors you have extracted in factor analysis, they are further used for the verification in structure equation modeling. So these are the factors they will be used in factor analysis. So under factor structure equation modeling, first factor will consist of V1, V3 and V5. Second factor will consist of V6, V4 and V5 variables, right? And so on. There may be third, fourth variables. And you can see the graph. Factor number 1, which prevent cavities, strengthen gums, and tooth decay benefit offer. They are along x-axis. That is health benefit factor, and this is cosmetic benefit factor along y-axis. So if somebody asks you that if I'm looking from the health point of view, which variable is most important for me? So which is having the highest weight? So this is having highest weight. To buy a toothpaste that prevent cavities. If somebody asks you which is the most important factor as far as the cosmetic benefits are concerned, this is the most important. Buying a toothpaste for attractive teeth, having the highest weightage. So this is how we conduct factor analysis, and hopefully I have explained you the technique of factor analysis. If you have any question, any query, you are most welcome to ask. Sorry for being taken 10 minutes extra because I have to finish this topic. All right. Any questions, please? You can ask me. Yes, please. Any questions?
Yes, you can unmute yourself. You can unmute yourself and ask question.
So actually, sometimes during the data analysis, during factor analysis, the data get overlap. Then, then how we will look at which will be more beneficial for us?
Very nice. Very nice. Let's say, yeah, the question is sometimes there is a variable which comes under factor 1 also, and it can also come under factor number 3. It can happen. You might have seen, right? This is your question, right?
Yes, sir.
Hello?
Yes, sir.
Now, then you look for the loading. Then you look for the loading. Let's say under factor 1, its loading is 0.321. But under factor number 3, suppose its loading is 0.713. Then you remove that particular loading and then read this, that it should go under factor 4 rather than factor 1. This is how the cross-loading is being checked.
So the highest one will be more effective.
Highest one will be taken. Where the highest loading is there, you take that variable under that particular factor, not which is having the low loading.
Okay, sir. Thank you.
You follow my point?
Yes.
Any other question, please?
Yes, sir. Good evening, sir.
Yeah, good evening. Yes, please.
I am Ajay Kumar Yadav from Bharatiya, sir.
Yes, please.
Sir, what is the difference between R and R square, and what is MCDM method?
Of course, I have not covered
research.
Okay, I have not covered this topic of R and R square, but you see, whenever we are dealing with only 2 variables, y and x, and you are looking for relationship like simple linear regression, we compute the value of R. R will give you strength of the relationship between 2 variables only. But if you are looking into multiple correlations, say y depends upon x1, x2, or xk number of factors, then we compute R square. Then there is adjusted R square also, right? Now,
any idea about MCDM method, sir? That is related with research. MCDM.
What is MCDM? Tool, no, I don't have any idea. I'm statistics teacher, not mathematics.
Sir, I write maybe my question in chat box.
Okay, let me just go through your question in chat box. What you have written? Nothing. MCDM. This is not a statistical method. Let me tell you. Maybe some mathematical procedure.
But sir, this is a mathematical, but it is related with some research tools, sir.
Which tool? Which tool?
Research.
What is the full form of MCDM? Then I can explain.
Presently, sir, I do not know full form, but sir,
multi-criteria discriminant. Multi-criteria
but I want to know about this topic, sir.
This is not from statistics.
And I request then in next
This is
session,
not from
please share,
statistics.
Okay, sir.
This is called multi-criteria decision making.
Decision making.
Yeah. Maybe it is a part of special data analysis, or maybe correspondence analysis, something like that. But I'm not sure what is this MCDM. It doesn't come under the domain of statistics. Yeah. Any other question, please?
Okay, thank you, sir.
Any other question? Any participant? Yes, please. Any participant?
Hello, sir. Good evening, sir.
Yeah.
This is Shomnath Dotto from
Yes,
West Bengal. My question is simply, suppose your version is SPSS 23. My SPSS is version 20. So in that case, in the output result of the factor analysis, in the rotated component matrix, all the data are not in a properly descending order. Okay, in that case,
it will be.
It will be. So in that case, how to deal with the situation as specifically for the cross-loading case?
No problem at all. No problem. Whether you are using SPSS version 20, whether you are using 23, 24, 27, 26, your output will be same. Exactly, the output will be same. There will be no difference in output. Not at all.
Yeah. Okay. So in that case, as per my earlier question, that means if there is any cross-loading, so we will take that variable under that factor which has highly loaded.
Exactly. This is what I told you.
And in your result under factor 1, the third variable has got a negative minus 0.933 something else. So what does it negative means?
Yeah. Okay. Negative and positive doesn't matter in factor analysis. It is just a loading.
Okay.
It doesn't matter in factor. You just look at the absolute value.
Okay. Thank you, sir. Very much. Welcome.
Any other question?
Sir.
Yes, please.
Good
Any
evening,
other
sir.
question? Yes.
Sir.
Yes, madam.
Sir, you said like in the previous example, there were maybe 120 variables. You said an example, sir. Am I audible, sir?
Yes, you are.
So you said 120 variables, and now in this example, you say there are 6 variables, like variable 1, V1, V2 till V6. So when we run the factor analysis, do we get like if we have 120 variables, we'll get 120 components?
Yes, and you will, but only those components will be important whose eigenvalue is more than 1.
Okay, sir. Thank you.
Yeah.
Sir, I have another
to look
question.
For the corresponding. Yes, please.
Suppose, sir, I have a certain dependent variables, say, for example, socio-economic benefit of tourism, and that depends on, suppose, 10 or 12 factors. Now, how, in case of importance, because people are attaching different importance to different factors.
It's a problem of regression, because one is a dependent variable, others are independent variable. So it's not a problem of factor analysis. It's a problem of regression. And somebody will cover, I think, regression part.
Okay. So may I use the PCA for finding that weightages? That is my question.
You can use
PCA method can be applicable to find that weightage or importance.
PCA, if you want to apply, you can apply. Do not include the dependent variable then. Only independent variables you can. Only independent variables. Then you can do that.
Okay.
Yes.
Thank you.
Multiple regression analysis will be covered tomorrow.
Okay. Thank you.
That will be covered.
Okay.
Yeah. Anybody else? I am happy that you are asking question at 9:30 almost.
Every time it is happening, sir. Whenever we are conducting any FDP together, every time it is happening.
No,
so there is no problem.
That is important.
Yeah.
Anybody. Yeah. You are most welcome to ask. Yes, please.
Anyone, please unmute yourself and ask your question.
All these people, they understand Hindi or not? They understand Hindi? No.
No, sir.
Yes, sir.
Abhijit,
no, sir.
yes, please.
Yeah.
Okay.
Abhijit, please continue.
Yes, sir. While you did this factor analysis, sir, the process you did on the SPSS, the last section, I could not check out. It was very fast. So will there be a possibility of showing the factor analysis to SPSS once more?
I have to share the screen. That's all. I have to share the screen. Can I share the screen again? Is it possible? I mean, if there is time is permitting, I can do that. Let me share the screen. Just it will not take much time.
You can, sir. You can.
Wait for a minute. Sure. And I'll answer the other question also in the meantime. Can you see the screen now?
Yes, sir.
Yeah. Okay. Let me open the data set. Yeah, I run this analysis, then go to dimension reduction, go to factor. If you remember, I have taken all the variables, control A, all the variables on this side. That's okay? Yes, please. Who was asking this question? Please.
Yes, sir. Yes, sir. This part is okay.
Then go to descriptive. In descriptive, you click on to univariate, coefficients, significance, reproduced, KMO. Do not click determinant, anti-image, inverse. They are not required. They are required for something else. Continue. Then in extraction, you have to go for principal components. That is by default. Scree plot and continue from here. Then in rotation, you go for Varimax procedure and loading plots. Continue from here. And in scores, you can save this as a variable. Continue from here. And in options, you click on to sorted by size and suppress small coefficients which are less than say 0.3 and continue. This is what I explained. Is this okay? Press OK and you will get the same output.
Yes,
you will get the same
just output. In the rotation, it was Varimax and then?
After Varimax, then you go to sorted by size. That's all.
Sorted by size. Okay, sir.
And somebody asked me this question because what are these factors actually? These factors are already here. This is your factor number 1, factor number 2. Since we have saved the last one also. So let me cut this because 2 times initial was also saved. So if you see the relationship between F1 and F2, they will be uncorrelated. Let's see. Go to analysis, go to correlate, go to bivariate, and this is factor number 1, this is factor number 2, and you must check their correlation, Karl-Pearson correlation coefficient, and you will see this is 0. So correlation between factor number 1 and factor number 2 is 0. You can see. That's why they are uncorrelated, because we have applied the Varimax procedure. And somebody has asked me this question because since I have opened the screen also, I'll go through quickly one example where you will see the cross-loading. Do you want to see cross-loading? Yes, please.
Yes, sir, definitely.
Yes, sir, sure.
Yeah. I'm just explaining you the cross-loading also. Because I have opened one more time. So just give me 1 minute. How to deal with cross-loading. Okay. So this is a very large data set. There are 18 variables, right? And I think more than there are 80 observations. So let me apply factor analysis. There is no name, nothing given. So let me apply. Do not include the serial number. This is just a serial number. So your variables start from x1, x2. They are on, I think, 5-point scale. All right. Go to analysis. Go to dimension reduction factor. And take this variable right up to this variable on this side. Do not take the serial number. Then go to descriptives, univariate, coefficient, significance level, KMO, and reproduced. Continue. Extraction, scree plot. Continue. Rotation, Varimax, loading plots. Continue. Scores, save as variable. Continue. Options. Let's say because it's a large data set, so I can sort it by size, say less than 0.4. Continue. That's all. So you will see the problem maybe of cross-loading here. So it's coming up. Just wait for a moment. So first of all, look for the KMO and Bartlett. KMO is 0.64, which is between 0.5 to 1. That's okay. Bartlett test is also significant. Commonality. Now look for the commonality. All the variables are having commonality more than 0.5, except this one, X17. Can you see that? Yes, please. Hello?
Yes, sir, it is visible. Please continue.
So this is slightly less than 0.5. So these variables can be removed before going into SEM, structure equation modeling. Okay. Now, how many factors have been extracted? Those eigenvalues, these are eigenvalues, 3.9, 2.9. So 6 factors have been extracted and the total variation is about 65%. Okay. Then this is a scree plot. Now go to rotated components straight away. This is rotated components. Now here you can see certain cross loadings. Can you see that? Yes, please. Hello.
Yes, sir.
So what is this factor? X15 is falling under factor number 2 also, and this is coming under factor number 5 also. So what to do? Which is having highest loading? Yes, please. Forget about negative or positive sign. Which is having highest loading?
5. In case of factor
5. So what I'll do, I'll just click here. I'll just click here and then click and cut from here. This is how I read. Similarly, this is having low loading. I'll cut from here. Similarly, this and this is having low loading. I'll cut from here. Now I think there is no loading. So this is your factor number 1, factor number 2, factor number 3, factor 4, 5, and 6. So this is how, this is also, this has to be removed from here. Cut. So take these factors, 6 factors for further analysis in SCM, structure equation modeling. This is how to do. Deal with cross loading. Is that okay? Hello?
Yes, sir.
Okay, sir. Thank you, sir. Clear, sir.
Yeah. Any other question, please? I'm stop this sharing now. Any other question? No question now?
There is no much more questions, sir. You have already clarified. Very.
My some questions in chat box, sir.
Your question is in chat box. Let me see. What is your question?
So if you have any further question, please send an email to us. We will forward the question to the resource person so they can respond to us. There is no problem because we have a time constant.
No. This is very simple question. He says Kolmogorov-Smirnov test. This Kolmogorov-Smirnov test is checking the normality actually, normality of the data. So to check the normality of the data, it is given in SPSS. And you can check the normality of the data through Kolmogorov-Smirnov test, generally called KS test. Since somebody will cover this, sir, parametric and non-parametric part.
Good evening, sir.
ARIMA test.
Pardon?
Sir, can ARIMA model used in the time series?
They are used in time series. I'm not covering time series here. I'm covering factor analysis.
Okay.
Yeah. Anybody else?
Good evening, sir. I am Aisha Jamal.
So there is one important question here. Is there any outlier how to remove in factor analysis? You see, outlier is that quantity where commonality is less than 0.5. If commonality is less than 0.5, particularly you remove that variable and then run the factor analysis. That is basically an outlier, how to detect it. Yes, please. Next one. Aisha Jamal, yes, please.
Yes, sir. This question may come as a very basic one, but I have been using SPSS during my PhD days. Okay, I was placed in a central university there. Now I'm posted in a state university, and our university is not having this SPSS software, and this SPSS software is rather costly. And if I have to get our research scholars to get the SPSS software, I just don't know how to provide them.
Yeah,
I'll
give you answer. Listen to me, please. See, the trial version is available for 30 days. You can run it for 30 days, right? That is one option. Another is that there is a different modules of SPSS. If you buy only the basic module for your institute, it will cost you around 1.5 lakh, just 1.5 lakh. The entire module of SPSS comes to around 9 lakhs now. But if you only need basic module, it will come to 1.5 lakh. And for an institute, 1.5 lakh is a very meager amount. It's not much.
Thank you, sir.
Any other question? I think we should stop now. Huh?
Yes, sir. Yes, sir.
जाते एक शेर सुना दें, हिंदी में शेर सुना दें.
Sure, sir. Sure. Go ahead.
चलिए आखिर में एक शेर सुना देते हैं जिनको हिंदी समझ में आती है. जिनको नहीं आएगी उनको इंग्लिश का शेर भी सुना देंगे. तो पहले हिंदी का सुन लीजिए, फिर इंग्लिश का. पहले हिंदी का. कि आज आपसे मुलाकात हुई है तो अच्छा लगा कि खूबसूरत सा एक पल जो आपके साथ बिताया हमने, कि खूबसूरत सा एक पल किस्सा बन जाता है, ना जाने कौन कहाँ जिंदगी का हिस्सा बन जाता है। कुछ खास लोग यानी आपकी तरह कुछ खास लोग मिलते हैं जिंदगी में इस तरह, जिनसे ना कभी बिछड़ने वाला रिश्ता बन जाता है। तो ये आपको शेर सुनाना चाहता था। और आखिर में जो लोग हिंदी नहीं समझ पाते उनके लिए इंग्लिश का शेर है। मैंने आपको रास्ता थोड़ा दिखाया है, ट्राई टू अंडरस्टैंड ऑल द टेक्निकलिटीज एंड देन उनके लिए के गुड बेटर बेस्ट, लेट्स नॉट रेस्ट टिल गुड बिकम्स बेटर एंड बेटर बिकम्स बेस्ट। थैंक यू।
So we are at the end of
We
the
are
session.
running short of time.
Yes. So from our end, from Bharatiya Vidya Institute of Management Science, Professor Sriparna Bhattacharya is there for vote of thanks. Please, madam, continue.
Yes, good evening.
एक रिक्वेस्ट।
Yes, am I?
मैडम आप पहले मैडम ये बताइए, आपको हिंदी समझ में आई जो मैंने बोला?
हाँ सर, एकदम।
अच्छा चलिए, गुड।
So I express my profound appreciation and contentment with gratitude as we come to the close of this enriching and enlightening first day of our 1 week faculty development program on multivariate data analysis, on multivariate data analysis and structural equation modeling using SPSS, organized by Bharatiya Vidya Bhavan Institute of Management Science, Kolkata, in associations with SPSS South Asia Private Limited and Indian Economic Association. It has been an evening filled with insightful lectures, lucid presentations, and meaningful interaction that have set the tone for what promises to be a week of profound learning and professional growth. First and foremost, I would like to express our sincere thanks to Dr. Suresh Kumar Sharma, Professor, Department of Statistics, Panjab University, Chandigarh, our distinguished resource person for today, who shared his expertise and knowledge on the factor analysis by his lucid presentation on a daunting topic. Your engaging and informative session has laid a solid foundation for the rest of this week, inspiring us to delve deeper into this subject matter. A special word of thanks, Dr. Sudipta Kumar Ghosh, Assistant Professor, BIMS, without whose tireless effort and meticulous planning, this FDP would not have been possible. I would also like to extend my heartful gratitude to the collaborators, Professor V.K. Malhotra, President, Indian Economic Associations, on behalf of the Indian Economic Associations and SPSS South Asia, and the organizing committee members at BIMS. Your dedication and commitment to ensuring a seamless and productive event are truly commendable. I would also like to acknowledge the support of our Honorable Director, Dr. G.V. Subramaniam, and Principal, Dr. S.P. Mahapatra. Your commitment to education and professional development is evident. I extend my gratitude to all the participants, our enthusiastic participants who actively contributed to this discussion and asked thought-provoking questions. As we look ahead to the remaining days of this FDP, let us carry the enthusiasm and spirit of collaboration that we have witnessed today. So wishing you all a restful evening and looking forward to seeing you back here tomorrow for another day of learning. Thank you. Thank you, sir, for these wonderful sessions.
Thank you, madam. And all the participants, I have shared the feedback and attendance form in the chat box. And I will also share this feedback link through email. Please fill up the feedback form regarding this session, and we will meet you again tomorrow 7 p.m. Please be there. And again, I am really thankful to Professor Suresh Kumar Sharma accepting our invitation. Thank you, sir. And taking the permission of our principal, sir, we are ending the session here.
Okay.
Thank you.
Sure.
Thank you so much.
Okay, thank you. Thank you.
Thank you all. Thank you.
Thank you.